Hello everyone, a very good evening all of you and a very warm welcome to you all to this wonderful session for the engineering science paper. I hope आप लोगों का मैकेनिकल पेपर गेट 2024 बहुत अच्छा गया होगा. Now you guys must be focusing on the second paper and you must have filled the second paper as engineering science. तो आज के डिस्कशन में वी विल बी गोइंग टू डिस्कस सम इंपॉर्टेंट प्रीवियस ईयर क्वेश्चंस विच हैड बीन आस्क्ड इन गेट एक्सई पेपर, ऑलराइट, फ्रॉम द फ्लूइड मैकेनिक्स सब्जेक्ट. So please do let me know if my audio and visual quality are fine. Can you guys properly hear me? Those who are watching me live, respond me through the comment section if my audio and visual quality are fine. Shall we start? Any question you were not able to solve in mechanical engineering paper from the fluid mechanics, you can just let me know. Hi Aniket, good evening, welcome. नमस्कार, आदाब, शुभ संध्या, गुड इवनिंग, सत श्री अकाल, अस्सलाम वालेकुम, वणकम. Please get yourself settled down fast so that we can start the wonderful session at the earliest. For those who are attending my session for the very first time, this is my quick introduction. I am having more than 10 years of teaching experience. I'm a mechanical engineering graduate from IIT Delhi. Also cleared engineering services examination, worked in SAIL for a couple of years. And I am quite comfortable in fluid mechanics, heat transfer, thermal and industrial. How was your GATE 2024 paper? How was the difficulty level? How did you find it? Please keep your pen, notebook and calculator and try to solve as many questions as possible on your own, because once you will be solving the questions, then you will become more confident and you will have the better understanding of the concept. So this is my quick introduction. This is the mail ID through which you can always connect with me, or you can join me on the Telegram. Aniket, the most important thing is practice. When your concepts are clear, but if you are lacking in the practice, you will not develop the confidence. You will always have a fear of attempting the questions. So that is why we always keep on telling the students that you should practice as many number of questions as possible before going for the final gate paper. The practice is the key. Because when somebody else is solving, for an example, if I am solving the questions in front of you, you will find each and every question very simple, because you will find each and every steps written in an organized manner. So you will think that the question is simple, but when you are going to attempt the question independently, then there lot of doubts start coming in your mind. What should be the unit of a given parameter? What should be the formula? What should be the diagram? Where we need to apply the Bernoulli equation? Which points we are supposed to select? So many questions start bothering your mind and you start getting confused. So that is why practice is the very important part of your preparation journey. You can join me on the Telegram as well. Mechanical by Chandrasekhar. The link is already there on the at the bottom of the screen. If you are already part of my Telegram channel, it is all fine. If you are not, do join me on the Telegram so that you can get lot of benefits for your efficient preparation. So even if your GATE examination did not go well, there is another chance. If you will perform very well in engineering science paper, you can easily get IIT for your MTech, right? Because the competition is also very less in engineering science paper. Moreover, you are getting another chance. The syllabus is more or less same. You can select fluid mechanics, you can select thermal engineering, thermodynamics, material science, or strength of materials or solid mechanics. 2 papers you are supposed to select, and the syllabus is more or less same. So it is going to be a golden opportunity. Focus on engineering science paper, and after the engineering science paper there are many opportunities. Yes, lot of opportunities are going to come in front of you in the near future. So keep on preparing, keep on having your preparation with your full dedication, hard work. Do not bother about the results. Do not think too much about anything else, but you should keep on focusing on your preparation. Try to improve your subjects, try to improve your technical part. Once your technical part is very clear, if you are quite comfortable in technical part, then you can get selected in ISRO, BARC, NTPC. There are many exams. There are a lot of organizations which conduct their own examinations. अनिकेत थोड़ा सा एक डिफरेंस है. पोटेंशियल फ्लो इज द वन पोर्शन, पोटेंशियल फ्लो which is extra in XE paper. That is extra, but in XE paper this hydraulic machine is not there. Hydraulic machines is not there. So one topic is getting added and one topic is getting removed. Now on 7th of Feb, day after tomorrow, there will be an interactive workshop for all the GATE 2025 aspirants. So share this information to all your friends, juniors, colleagues who are thinking of appearing for GATE 2025 examination. So the link to register yourself is already there in the description box. In the description box of this session, there are a lot of links, so many links which are important for your better preparation. So go through the description box once. And if you have not liked this session, please do like and share to all your friends, colleagues, and all your contacts who are preparing for GATE examination. So there was a question asked regarding the rheological behavior of the fluid. The rheological diagram of different fluids is shown in the figure. Column 1, type of the fluid. Column 2, the graph. So Newtonian fluid, the graph between shear stress and rate of angular deformation or strain rate, d theta by dt. For Newtonian fluid, tau is directly proportional to d theta by dt, isn't it? And the slope will be, slope of the curve will always be viscosity of the fluid. And viscosity gives us the information whether the fluid is thick or thin, right? Thickness of the fluid. The slope of the curve will be the viscosity. So Newtonian fluid, when shear stress is directly proportional to rate of angular deformation, Newtonian fluid will be a straight line. O is the Newtonian fluid. O. 1O. Shear thinning, whose slope decreases. Thinning, the fluid becomes thin when the viscosity decreases. So P will be the shear thinning fluid. P, whose viscosity or the slope decreases. Shear thinning fluid is also known as pseudoplastic. Shear thinning fluids is also known as pseudoplastic. Pseudoplastic fluids. Pseudoplastic fluids. Then comes shear thickening. When the fluids becomes thick, the viscosity increases. When the viscosity increases, slope increases. So N is shear thickening. Shear thickening fluids are also known as dilatant. Dilatant fluids are shear thickening. And Bingham plastic is ideal plastic whose viscosity is constant, but there is a threshold shear stress required for the flow. OPNM. OPNM. B is the correct answer. Well done, Aniket. Good, good. Hi, Sayed. Good evening. Welcome. How are you? Everybody, please keep on sharing your answer. Try to solve it before I solve on the board and share your answer the way Aniket is giving. If the stream function for a 2D incompressible fluid flow is given by this expression. Stream function is given by this expression, the corresponding velocity field. So the velocity in x direction is del psi by del y. Yes or no? Can we write it as 2x square into y minus 2y cube? This is the expression. So del psi by del y is equal to 2x cube square minus 6y square. Yes or no? V is equal to minus of del psi by del x minus del psi by del x. So it will be minus 4xy. That's it. U and V, find out the value of U and V. And the velocity vector is equal to Ui cap plus Vj cap. Put the value of U and V from here. 2x square minus 6, or we can write it as 2x square minus 3y square I cap minus 4xy j cap. What is the answer? Isn't it B again? Is it B again? B will be the answer, right? B will be the answer. Let us move to the next one. Yes, question number 3. Water is flowing in two different tubes of diameter d and 2d with the same velocity. Here there is a catch. The velocity is same, velocity is constant. The ratio of laminar, the flow is laminar. Friction factors, Darcy friction factor for the larger diameter tube to the smaller diameter tube is. We need to develop a relation between friction factor and the diameter. And for laminar flow, we know friction factor is given by 64 by Reynolds number. And what is the Reynolds number? Reynolds number is rho into V into d by mu. Or we can call it as V into d by kinematic viscosity. When the velocity is constant, then Reynolds number is directly proportional to diameter. So if we put it here, then friction factor is inversely proportional to diameter. That is the relation. The friction factor for the larger diameter 2d upon smaller diameter. So it will be F1 by F2 is equal to D2 by D1. Sorry, larger diameter to the smaller diameter. Larger diameter is F2. This is D1, this is D2. So F2 by F1 is equal to D1 by D2. That is 1 by 2 will be the answer. It is 1 by 2. 0.5 will be the correct answer for this one. 0.5, option A. If the discharge would have been constant, try to understand. If the question would have given you the constant discharge rather than constant velocity. If Q is equal to constant, try to understand, then velocity is inversely proportional to d square. Yes or no? Then velocity would have been inversely proportional to d square. And if velocity would have been inversely proportional to v square, Reynolds number is directly proportional to velocity into diameter. So Reynolds number is inversely proportional to diameter. Yes or no? And if Reynolds number would have been inversely proportional to diameter, then friction factor would have been directly proportional to diameter. So in that case, F2 by F1 would have been D2 by D1. So it would have been 2. If the discharge would have been constant, then the answer would have been C. For Q is equal to constant, answer is C. For velocity is constant, answer is A. Do not commit these type of mistakes. Right? Whenever we are supposed to develop a relation between any two parameters, the constant terms are removed. The constant terms are removed from the relation. The variable terms are taken into consideration for developing the correct relation. Are you getting it? Sometimes the velocity could have been given as constant. Sometimes the diameter the discharge would have been given constant. The next one, if the velocity field is given by this expression, this is Ui cap plus Vj cap. Vorticity of the fluid element in the field at x is equal to 1 and y is equal to 2. What is the vorticity about z axis? So del v by del x minus del u by del y. That will be the vorticity. What is u? X into y square. What is v? 4xy. So put the values of del v by del x. What is del v by del x? 4y minus what is del u by del y? That is 2xy. At x is equal to 1 and y is equal to 2. What are the values? Vorticity is equal to 4 into 2 minus 2 into 1 into 2. So 8 minus 4, that is 4 second inverse. The unit of vorticity is second inverse. The answer will be 4. 4 आएगा ना Aniket, it will be 4. Yes or no? Isn't it 4? There is a negative sign here. There should be a negative sign. Let us move to the next one. The next question is, a pitot static tube is used to measure air velocity in a duct by neglecting the losses. It means coefficient of velocity will be taken as 1 and the losses are not considered. The density of air is 1.2 kg per meter cube. If the difference between the total and the static pressure, like this is the pitot tube, this is 0.1, this is 0.2. 0.2 is having total pressure, P1 is having static pressure because the velocity is V1. So P2 minus P1 is given as 1 kilopascal. What is the velocity of air at the measuring location? V1. V1 is equal to under root of 2gh. H is P2 minus P1 by rho g. By using the Bernoulli equation and by applying the Bernoulli equation and pressure equation, we will get this expression. G and G are getting cancelled out. So under root of 2 P2 minus P1 is 1000, 1 kilopascal is 1000 pascal upon density is 1.2. That is the velocity in meter per second. How much is the answer? 2000 divided by 1.2. Divide by 1.2 and take the square root of this. Are you getting 40.82? 40.82 meter per second. .82 meter per second. Yes. Next, the velocity field in a two-dimensional unsteady flow is given by this expression x, y and t. Velocity is a function of x, y and t. The magnitude of acceleration of the fluid particle located at x is equal to 1 meter, y is equal to 1 meter and the time t is equal to 1 second is. So because it is 2D flow, can we compare it with v is equal to u I cap plus v j cap? U I cap plus v j cap. So u is equal to 2xy square and v is equal to 3xyt. So if we find out acceleration ax, first of all calculate ax. Ax is equal to del u by del t plus u into del u by del x plus v into del u by del y. Right? Del u by del t, u is not a function of time. So this term will be 0. U, that is 2xy square into del u by del x is equal to 2y square plus v 3xyt multiplied by del u by del y. It is 4xy. This will be the expression. At x is equal to 1, at x is equal to 1, y is equal to 1, t is equal to 1. What is the value of ax? 2 into 2 plus 3, 1, 1, 1, 3 into 4, 4 plus 12, 16 meter per second square. It is only ax. It is only ax. The question is not about acceleration in x direction. This is only acceleration in x direction. People commit these mistakes. That acceleration in x direction, nahi abhi, Fluid machinery is not part of the engineering science syllabus. Fluid machinery will not be there. You should be happy that fluid machinery will not be there. Okay. But potential flow is there. Superposition of the potential flows. Uniform flow, doublet, etc. A small topic is there, which is part of the syllabus. Now, similarly, we can find out AY. Similarly, we can find out AY. If we compare, this is UI plus VJ cap. So, U is equal to 2xy square and V is equal to 3xyt. So, if we find out AY, acceleration in Y direction, calculate AY is equal to del V by del T, local acceleration, plus U into del V by del X. You should memorize the formula. Del V by del X plus V into del V by del Y. V is a function of time. So, del V by del T is 3xy plus U 2xy square into del V by del X, that is 3x del V by del X, na? 3yt plus V, that is 3xyt into del V by del Y, that is 3xt. That is the expression. So, at x is equal to 1, y is equal to 1, t is equal to 1. What is the value of AY? 3xy, that is 3 plus 2 into 3 plus 3 into 3. How much is that? 3 plus 6 plus 9, 18 units. It will be 18. AY will be 18, 18.1, 18. But our magnitude of the total acceleration is AX square plus AY square under root. So, our answer will be 16 square plus 18 square under root. What is the final answer? What will be the final answer? 16 square plus 18 square, and take the square root of this. Isn't it 24.08 meter per second square? That will be the answer. Yes, Aniket, well done. 24.1 will be the answer. C will be the correct answer. C will be the answer. Good, good, good. Everybody, please keep on solving these questions. This is how the questions are going to be asked. This is the difficulty level of the questions. For engineering science, believe me, the engineering science paper will not be very difficult, and that is the best or the simplest opportunity or simplest way to enter into IIT. If you are performing very well in your engineering science paper, then you will be easily getting IIT for your MTech. And once you get the IIT degree, then sky is the limit in your future, in your career. In a 2D flow, incompressible, in a two-dimensional, incompressible and irrotational flow, the fluid velocity V in Y direction is given by this expression. We need to find out the velocity U in X direction. Can you solve it? Because it is incompressible flow. So, if we apply continuity equation for incompressible flow, del U by del X plus del V by del Y is equal to 0. So, del U by del X is equal to minus of del V by del Y. What is minus of del V by del Y? That is equal to 5. Del V by del Y is minus 5. So, it will be 5. Now, if we integrate with respect to X, integrate this with respect to X, what do you get? Then U is equal to 5x plus a function of 5. Now, differentiate with respect to Y, then we will say del U by del Y is equal to f dash Y. This will give you the answer. Del U by del Y is f dash Y. Now, to find out this is equation number 1. Also, the flow is irrotational. Also, the flow is irrotational. For irrotational flow, do you agree vorticity, that is del V by del X minus del u by del y is equal to 0. Or we can say del u by del y is equal to del v by del x. What is del v by del x? That is 2. So this is equation number 2. If you equate 1 and 2, from equation 1 and 2, from equations 1 and 2, which test you are talking about, Rocky? From equation number 1 and 2. Do you know that during the examination also you can select the sections out of the given sections A to H, B to H? There are two sections you are supposed to select, and you can select after seeing the paper as well. And once you start solving a particular section, then also you can deselect that section and select another one. Rocky, there is no mock test as such. Solve the previous year questions, it will be sufficient. Solve all the PYQs. If you are going to select fluid mechanics, then solve all the fluid mechanics PYQs, previous year questions. It will be helpful. From equation number 1 and 2, f dash y is equal to 2. So if we integrate again, then fy will be equal to 2y, isn't it? Fy will be equal to 2y. So u is equal to, what is the value of u? U is equal to 5x plus f dash fy, 5x plus fy, and the value of fy is 2y. So it will be 5x plus 2y will be the answer. Isn't it C? Isn't it C? C will be the answer. Yes, Rocky. If you are able to solve last 7 year PYQs, solve the 8th year also. Keep on continuing your preparation. Keep on solving as many questions as possible till your final exam. That is how it works. And please try to revise one topic, that is potential flows. That is the part of your engineering science fluid mechanics syllabus, and do not go for hydraulic machines. That is never asked in the engineering science paper. Don't revise or don't solve the questions from the hydraulic machines, but potential flow, normally theoretical questions are asked, so you do not have to worry much, but that is the part of your engineering science syllabus. The next question, let us move to the next one. Question number 8. Question number 8. Give it a try. There is a water jet. The question is from the momentum equation. A water jet of 100 mm diameter. The diameter of the water jet is 100 mm, issuing out of a nozzle at a speed of 50. Jet velocity is 50 meter per second. V, velocity of the jet, strikes the vane. Vane means the curved plate, and flows along it as shown in figure. This is how the fluid is flowing. This is how the flow is flowing over the vane. The vane is attached to a cart. There is a cart where the vane is attached, and which is moving at a constant speed of 20 meter per second. What does that mean? It means the velocity of the vane is 20 meter per second. It means the blade is also moving. It is an example of moving curved blade. Whenever the blade is also moving or the plate is also moving, then we always talk about the relative velocity. We sit on the plate and write the momentum equation. If you are clear with that, if you know that, I hope you remember the fact that because the flow becomes unsteady when the surface is moving or the control volume is moving, then the flow becomes unsteady. To make the flow steady, we sit on the control volume or the plate and write the momentum equation. The jet is deflected at an angle of 30 degree. Take the density of water as 1000, neglecting the friction between the vane and the fluid. It means ideal flow. The magnitude of the force exerted by the water on the cart in x direction. Whatever the force exerted by the fluid on the plate is same as the force exerted on the cart because the plate is attached to the cart, isn't it? So the question is to find out the momentum equation in x direction. This is, let me call it as x direction. So force is, let us say, Fx. So Fx is equal to density into discharge mass flow rate rho into A into relative velocity. If you sit on this, which is moving with the velocity u, then the relative velocity of the fluid is v minus u into force on the plate. So initial velocity minus final velocity in x direction. V minus u is the initial velocity minus final velocity is v minus u cos 30. This will give you the answer. So it will be rho A v minus u whole square 1 minus cos 30. Put the values, you will get the answer. 10 to the power 3 pi by 4 d square. What is the diameter? Diameter 100 mm, 0.1 meter into v minus u 50 minus 20 square into 1 minus cos 30 under root 3 by 2. What is the answer? What will be the answer? Can you solve it? Are you getting 947 Newton something? Are you guys getting 947 Newton? Please check. Everybody please check in Newton. 1 minus root 3 by 2. Into 30 square 900 into 0.1 square, that is 0.01 into pi into 1000 divided by 4. 947.01. Yes, the correct answer is around 947. The next question, these type of questions are normally asked. Recently, these type of questions are asked from the model analysis, dimensional analysis. This is beautiful question. In GATE 2024 mechanical paper also, the question was asked from the dimensional analysis. Momentum equation चाहिए रोकी. देखिए momentum equation क्या होता है? That is the Newton's second law. Net force is equal to rate of change of linear momentum. Net force exerted is equal to rate of change of linear momentum, or the net force is equal to mass into acceleration. That is Newton's second law. We can also call it as momentum equation. Now our system is the fluid. Our system is the fluid. We will calculate the change in momentum of the fluid. When the force is exerted by the fluid, Fx is force is exerted by the fluid. When the force is exerted by the fluid, then rate of change of momentum of the fluid will be initial momentum of the fluid, because the fluid is exerting a force, then the fluid's final momentum will be less. Initial momentum per second minus final momentum per second of the fluid. And what is momentum per second? That is mass flow rate into velocity. That is the momentum flow rate. Momentum flow rate. And what is mass flow rate? Rho into A into V. Into V. This is the momentum. Rho A V square is the momentum per second. Right? So this is the mass flow rate, rho A V minus U. Because the plate is moving, that is why we will write the relative velocity. Rho A V minus U is the mass flow rate striking the plate per second into change in velocity. This is the initial velocity of the fluid, and this is the final velocity of the fluid in x direction. Initial velocity of the fluid in x direction is V minus U. Final velocity is also V minus U according to Bernoulli principle, because there is no change in potential energy, there is no change in pressure energy. But we are interested, momentum equation is a vector equation. We are interested in x direction. So there is a direction of velocity changing in x direction. Magnitude is not changing here. Whenever the fluid is striking on the plate, the magnitude of velocity is not changing, but because of the change in direction of velocity, the acceleration is produced. So there is a different velocity in x direction. The velocity in x direction is V minus U cos 30. This is the final velocity. This is the initial velocity in x direction. So the change in momentum, mass flow rate into change in velocity will be the change in momentum per second, and that is the force. Got it, Rocky? Is this clear? Mass flow rate into change in velocity I have written. But because the plate is moving, that is why we are considering the relative velocity, not the actual velocity. Relative velocity of the jet is V minus U, because both are moving in same direction. If the plate would have been moving in opposite direction to the flow, then the relative velocity would have been V plus U. The next one, capillary waves are generated in the sea. The speed of propagation of the waves is known to be a function of density. C, that is the speed of propagation of the wave, is a function of density, wavelength lambda, and surface tension sigma. Assume rho and lambda to be constant. If the surface tension is double in the functional form of the relevant dimensional group, the percentage increase in the propagation of the propagation speed is. So the final speed is, let us say, C2, initially C1, sigma 2 becomes twice of sigma 1, that is given. So C2 minus C1 upon C1 into 100 will be the percentage change, or C2 by C1 minus 1 into 100. So our objective is to develop a relation between C and sigma, isn't it? This will give you the answer. So how to develop the relation between C and sigma? So we can write C is equal to, or we can write here, C is equal to some constant into rho to the power A, lambda to the power B, and sigma to the power C. Equate the dimensional formula. P is L1 T minus 1 meter per second is equal to K is the constant parameter. Rho is M1 L minus 3 to the power A. Lambda is L1 to the power B. Sigma is Newton per meter. That is M1 T minus 2. That is the dimension formula to the power C. Equate the powers on LHS and RHS. M to the power A plus C. Then L to the power minus 3A plus B minus 3A plus B. And then T to the power minus 2C is equal to M0 L1 T minus 1. Now if we equate the powers, A plus C is equal to 0, one equation. Our objective is to find out this C, because both others are constant. A plus C is equal to 0, minus 3A plus B is equal to 1, and minus 2C is equal to minus 1. We are interested in this C only. C is equal to 1 by 2. Yes or no? The value of C is equal to 1 by 2. So we can say this speed of propagation of wave is directly proportional to sigma to the power 1 by 2. That will be the relation. So if we want to find out C2 by C1, then sigma 2 by sigma 1 to the power 1 by 2, and sigma 2 is 2, that is 2 to the power 1 by 2. What is 2 to the power 1 by 2? That is 1.414. Root 2, 1.414 C2 by C1. So if we get C2 by C1, put in equation number 1. This is our equation number 1. Put the values in equation number 1. These type of questions are important nowadays. Put in equation number 1, then we will get C2 by C1 is 1.414, 1.414 minus 1 into 100, that is 41.4% will be the correct answer. It is around 41.4. 41.4 will be the right answer. Let us move to the next one. Is this clear to everyone? Any doubt? If anybody is having any doubt, you are most welcome to ask. Again, the next one. Consider a fully developed two-dimensional and steady flow of a viscous fluid, that is laminar flow, between two fixed parallel plates. Normally, in GATE ME, questions are rarely asked from the parallel plates, but it is important for engineering science paper. Two fixed parallel plates. You revise all the formula related to the parallel plates separated by a distance of 30 mm. The dynamic viscosity of the fluid is given and the pressure drop per unit length is given as 300. That is del P by del X. 300. The fluid velocity at a distance of 10 mm from the bottom plate. 10 mm from the bottom plate is Y. There are two plates like this. The distance between the plates is H. This is Y is equal to 0. This is Y. This is Y is equal to H. So we need to find out. So the velocity is given by 1 by 2 mu minus of del P by del X into Hy minus Y square. If you remember this formula, what is the distance between them? That is H. H is given as 30. So 1 upon 2 into mu 0.01, that is the dynamic viscosity, into 300, then Hy minus Y square. H is 0.03 into Y, that is 10 mm 0.01 minus Y square 0.01 square. That will be the answer. That will be the answer. Can you solve it? .03 into 0.01 minus 0.01 square into 300 divided by 0.02. 3 will be the correct answer. The velocity is 3. The velocity is given by 3. Right? The velocity is 3. Question number 11. Next one. A 2.6 gram smooth table tennis ball has a diameter of 38 mm. There is a ball having a diameter of 38 millimeter. That is the diameter. Density of air is 1.2 kg per meter cube. Neglect the effect of gravity. Take coefficient of drag as 0.5. Average drag coefficient. If the ball is struck with an initial velocity of 30 meter per second. If the ball is moving with a velocity of 30 meter per second, that is u. This is air, let us say. The initial deceleration is. So there is a drag force acting by the air in the direction opposite to the motion. So because the drag force is opposing the motion, so there is a deceleration. So this mass into acceleration is equal to Fd, isn't it? That is the deceleration because it is acting in opposite direction. Acceleration is decreasing. That is the retardation. Initial velocity is u. After some time it will stop. So we can say m into a is equal to CD into projected area into rho u square by 2. What is the mass? 2.6 gram. 2.6 into 10 to the power minus 3 kg into acceleration. CD is 0.5. What is the projected area? Projected area will be area of a. Hi Karthik, good evening. Projected area will be the area of the circle. For a sphere, the projected area will be the circle. Pi by 4d square. Do not make this mistake. It is the projected area. It will not be the area of the sphere. It must be the projected area. Pi by 4d square. The diameter is 38 mm 0.038 square. Into rho, what is the density? 1.2 divided by 2 into u square. What is the initial velocity? 30 meter per second. Yes, that will give you the answer. Can you solve it and find out the value of A? Solve it and find the value of A. Quickly, everybody. Are you guys getting 117.77 meter per second square or not? Are you getting this 117.77 or not? Tell me if you are getting this. The next one, over a flat plate, on a flat plate, transition from laminar to turbulent boundary layer occurred at a critical Reynolds number. The transition of boundary from laminar to turbulent takes place at the critical value of Reynolds number. The empirical relation for the laminar and turbulent boundary layer thicknesses are given by, for turbulent this is given by this expression. That is what we know. Re to the power 1 by 5. Rex to the power minus 0.2. That is in the denominator Re to the power 0.2. 0.2 is 1 by 5. And for laminar it is given by this expression, that is Reynolds number to the power 1 by 2 in the denominator, right? The ratio of laminar to turbulent boundary layer thicknesses at the location of transition is 0.3. So delta laminar to delta turbulent is given as 0.3. We need to find out the value of Reynolds number. So delta laminar is equal to, if we put the value delta laminar, we will write 5.48 into Reynolds number to the power minus 0.5 upon x, and into delta turbulent we can write 0.37 into Reynolds number to the power minus 0.2 upon x. X and x are getting cancelled out, so that is equal to 0.3. We can easily find out the value of Reynolds number. Can't you find out the value of Reynolds number? 5.48 upon 0.37 into 1 by Reynolds number to the power 0.3 is equal to 0.3, isn't it? Sorry, it is 3 na? Minus 0.2 plus 0.5, 0.3. So can you find out the Reynolds number? So Reynolds number to the power 0.3 is equal to 5.48 upon 0.37 into 0.3. And what is the Reynolds number? That is the critical value of Reynolds number. 5.48 upon 0.37 into 0.3 to the power 1 upon 0.3 will be the answer. Can you solve it? Can you guys solve it? This is how you will get the answer. The value will be 5.48 divided by 0.37 divided by 0.3 to the power 1 divided by 0.3. 441,426.7. 441,426.7 will be the value. Yes, that is correct, Aniket. That will be the answer. The next one, question number 13, that is laminar flow in a pipe or in a tube. In the capillary tube, it is internal flow. It is an example of internal flow. In the capillary tube of radius 0.25 millimeter, a fully developed laminar velocity profile is defined. They might not have given you this. You must remember U maximum 1 minus R square by capital R square. That is the velocity profile, parabolic velocity profile for laminar flow in a pipe, where dP by dx is given as 1 megapascal. ये थोड़ा गलत कर दिया ना. It is not 1 minus del P by del x. Is it 1 minus del P by del x? There is a mistake. It is not 1 minus, it is minus del P by del x. Yes, it will be minus del P by del X. This is U maximum. This is the maximum velocity. Mu is the dynamic viscosity and R is the radial position from the center line of the tube if the flow rate through the tube is 1000 millimeter cube per second. The viscosity of the fluid in Pascal second. It means dynamic viscosity is asked. Discharge is given, we can find out the average velocity. Or what you could have done is directly Q is equal to pi by 8 mu minus del P by del X into R to the power 4. You could have used this expression, that is equal to area into average velocity. So if you will use 1000 millimeter cube per second, so discharge will be equal to 1000 into 10 to the power minus 3. 1 millimeter is 10 to the power minus 3 meter cube is equal to pi by 8 mu. Mu is unknown into minus del P by del X. 1 into 10 to the power 6 megapascal into R to the power 4. What is the radius? Radius is given as 0.25. So 0.25 into 10 to the power 0.25 millimeter. Yes, 0.25 into 10 to the power minus 3 to the power 4. The only unknown is mu. Do calculation correctly, then you will get the correct answer. This term, please do the calculation correctly. Can we say this term, that is 10 to the power minus 6, and this is also 10 to the power minus 6, here also 10 to the power minus 6. So this will get cancelled out like this. So mu is equal to pi by 8, sorry, mu is equal to, yes, pi by 8 into 0.25 to the power 4. That will be your answer, Pascal second, isn't it? क्या 0 होगा? So pi into 0.25 to the power 4 divide by 8. So it will be, सही लिखा है क्या मैंने? 1.534 into 10 to the power minus 3. Mu is equal to 1.534 into 10 to the power minus 3 Pascal second. Yes or no? Are you getting this value or not? Minus 6 थोड़ी होगा. It will not be minus 3. It will be minus 3. यही तो ध्यान से करिए इस कैलकुलेशन. It should be 1.534 into 10 to the power minus 3. Yes, Aniket, check your calculation. Let us move to the next one. Yes, take care of the mistakes, because if you will commit the mistake in the calculation, then your entire effort, whatever you have applied the concept, even if you have applied the correct concept, then because of the calculation mistake, because of the silly mistake, you can get the incorrect answer. And in NAT, it is very, very important. In MSQs, MCQs, even if you are not getting the correct answer, you can check the options and from there you can get a hint to recheck your calculation. But if it is an NAT, then You should take special care to get the correct calculation, to do the correct calculation in the first attempt only. A 150 by 150 square pillar. This is the square pillar. 150 by 150 is located in a river with water flowing at a velocity of 2 meter per second. The water is flowing with a velocity of 2 meter per second. The fluid is water. The height of the pillar in water is 8 meter. The density of water is 1000. Kinematic viscosity is 10 to the power minus 6. The coefficient of drag of the pillar is 2 CD. The drag force exerted by water on the pillar. Simple. So drag force is equal to CD into again the projected area into rho u square by 2. Very simple. What is the projected area? Projected area is the frontal area. This will be the projected area. This will be the projected area. So that will be 8 multiplied by 8 meter by 150 mm, 0.15 meter square. Projected area will be this. So CD2 into 8 into 0.15 into 10 to the power 3 into u square, that is 2 square upon 2. 150, convert 150 into meter. So 0.15. The answer you will get in Newton. So 16 into 16,000 into 0.5. Sorry. 32,000 into 0.15. 4,800 will be the answer. 4,800 Newton. The drag force will be 4,800 Newton. Question number 15. The next one. I will discuss 25 questions from BYJU'S. Let us solve question number 15. An orifice plate. This is the orifice plate. An orifice plate is used to measure flow rate of air. Density is 1.23 in a duct of 250 mm diameter as shown in figure. The diameter of the pipe or the duct is 250 mm. It is a circular duct. The volume flow rate is 1 meter cube per second. Flow at sections 1 and 3 is uniform. At 1 and 3. Diameter are same, V1 is equal to V3. D1 is equal to D3, V1 is equal to V3. According to continuity equation, flow at section 1 and 3 is uniform and section 2 is located at vena contacta. This is, let us say, section 2. This is section 2, which is at vena contacta. This is point 2. So the fluid will be moving like this. Like this. This is how the fluid flow will take place. The diameter ratio dt is the diameter of the orifice upon d1 is 0.66. The flow area at vena contacta, that is A2, is 0.65 AT. Or we can say A2 is equal to 0.65 AT. Can we say pi by 4 d2 square is equal to 0.65 into pi by 4 dt square, because the pipe is circular. So we can say d2 square is equal to 0.65 dt square. Yes. Now the question is the pressure difference between location 2 and location 3 is 2 is this point, 3 is this point. We need to find out the pressure difference between 2 and 3. So how to solve it? Pressure difference between 2 and 3. Apply Bernoulli equation between 2 and 3. This is 2, this is 3. Bernoulli equation between points 2 and 3. So we can say P2 plus rho V2 square by 2 is equal to P3 plus rho V3 square by 2 in terms of pressure. Z2 is equal to Z3. There is no change in potential energy. They are very, very close to each other points. So the question is to find out the pressure difference between 2 and 3. So P3 minus P2 is equal to rho by 2 V2 square minus V3 square. Yes or no? And V3 can be written as V1, isn't it? V3 is equal to V1. So this is equal to P3 minus P2 is equal to rho by 2 V2 square minus V1 square. And the flow rate is 1 meter cube per second. So we can find out the value of V1. How to find out the value of V3? If we take V1 square common, can you solve it? If we take rho by 2 V1 square common, then it will be V2 by V1 whole square minus 1. And V2 by V1 is equal to A2 by A1. V2 by V1 is A1 by A2. So we can write P3 minus P2 is equal to rho by 2 into V1 square, then A1 by A2 whole square minus 1. Or we can write rho by 2 V1 square into A1 by A2 is D1 by D2 whole square minus 1. Now dt by d1 is 0.66, dt by d1 is equal to 0.66, and so from here d1 is equal to dt by 0.66, and from here d2 will be equal to, or d2 square is equal to 0.65 dt square. So put the value of d1 and d2. So that is equal to rho by 2 v1 square, then d1 dt by 0.66, so dt square by 0.66 square, then d2 square, that is 0.65 into dt square minus 1. This dt square getting cancelled out. So the expression will be P3 minus P2 will come out to be rho by 2 V1 square. What is V1? Rho by 2. V1 is 4q by pi D1 square. Into 1 upon 0.66 square into 0.65 minus 1. If we put the value, what is the density? What is the fluid flow rate of air? Density is 1.23. 1.23, this will become 2 into 2 into discharge is 1 upon pi into d1, 250 mm, 0.25 square multiplied by 1 upon 0.66 square into 0.65 minus 1. That will give you the answer. Can you find out P3 minus P2? Do the calculation correctly and you will get the answer. 1 divided by 0.66 square, then divide by 0.65 minus 1 into 2.46 divide by pi divide by 0.25 square. Your answer should be 31.72. Are you getting something around? थोड़ा गड़बड़ हो गया क्या? आर वी गेटिंग, इज देयर एनी कंफ्यूजन? यहां पे कुछ मिस्टेक हो गया क्या? 31.72 in Newton per meter square. Let me quickly check. Is the answer correct or incorrect? Just hold on. There is some mistake. Mistake कहाँ हुई है? There is some mistake in the question. An orifice plate is used to measure the flow rate of air in a duct of 250 mm. The volume flow rate is 1 meter cube. So from here we can find out V1. V1 is equal to 4 q by pi d1 square. What is V1? 4 divided by pi divided by d1 square, 0.25 square, 20.37. V1 is 20.37. 20.37. And then the V3 is also same as V1 because D3 is equal to D1. 20.37. Yes. And then the flow rate section 1 and 3 is uniform. dt by d1 is 0.66. So we can find out dt. dt is this diameter. We need to find out d2. How you can find out d2? d2 square is equal to 0.65 dt square. And what is dt? From here we can find out dt. dt is equal to d1 into 0.66. So 0.66 into d1, 250, 165 mm. dt will be 165 mm. And d2 will be equal to a2 is equal to 0.65 at. So d2 square is 0.65 dt square. So d2 is equal to under root of 0.65 into dt into under root of 0.65, 133.02. So d2 will be equal to 133.027. So these are the values. So if we put the values directly here, rho by 2 v2 square minus v1 square, rho by 2 v1 square, v2 by v1 whole square, a1 by a2, d1 by d2 whole square minus 1. So it will be rho by 2 v1 square. What is the value? Rho by 2 v1 square 1.23 divided by 2 into 20.37 square into d1 square by d2 square minus 1. d1 square is 250 square. 250 square upon d2. What is d2? d2 had been calculated 133.027. 133.027 square minus 1. Can you simplify this? Are you getting the same answer or not? 250 divided by this answer, then take the square minus 1 into 20.37 square into 1.23 divided by 2. 1292. There is some mistake. 646.08. अभी अलग आंसर आ रहा है. Have you understood the concept? This is how the question will be solved. Find out D2, find out D2 and D3. You just have to find out D2 and D3. V2 square minus V1 square over 2 V1 square. It should have been to the power 4. Here I had committed the mistake. It should have been the power 4, isn't it? It should have been power 4, because A1 by A2 whole square is D1 by D2 to the power 4. Are you getting it? Here also it should have been power 4. It should have been power 4. Now what will be the answer? It should have been power 4. Yes or no? No need to write this. Calculate D1 and D2 and to the power 4. Now what will be the answer? 250 divided by 133.027 to the power 4 minus 1 into 1.23 into 20.37 square divided by 2. 2927.9. It is around 2928 Newton per meter square will be the answer. It is 2928. The final answer, the correct answer will be 2928. Yes, that is correct. It is around 2928. That will be the answer. dt by d1 is 0.66. Given is dt by d1 is equal to 0.66. So we can say from here dt is equal to 0.66 into d1, that is 250. So dt is equal to 133, sorry, dt is equal to 165. 165 mm and d2 square is equal to 0.65 dt square. d2 square is equal to 0.65 dt square. So d2 is equal to 133.027 millimeter. If you are able to find out dt and d2, d1 is given. So put the values here, you will get the answer. It will be power 4. 2927. Yes, that will be the correct answer. So we are running the courses for GATE 2025 as well as 2026 aspirants. If you are preparing for GATE 2025, 2026 or you are preparing for other competitive examination, you can enroll yourself for our paid courses. And if you want to know more details about the courses, the fee structure, the various things we are providing you like live classes, recorded lectures, study materials, etc., you can contact the mentioned number, or for one-to-one guidance, you can call the number for the counseling, or you can fill the counseling form which is already there in the description box. All right, so let us move to the next one, question number 17. Let us talk about question number 17. This is from the pressure equation. The question is from the pressure equation. A differential U2 manometer with mercury modus the manometric fluid is used. This is water and the mercury is the manometric fluid. Is used to measure the pressure difference between two sections P and Q. There are two sections P and Q. To find out the pressure difference, this type of manometer is used in a horizontal pipe carrying water at a steady state as shown in figure. If the difference in mercury level is given as 0.75, difference in mercury level is, this is 0.7, this is 0.75. आपके पास कौन सी बुक है अनिकेत? दैट इज नॉट करेक्ट आंसर. ये आंसर कहां से देखा आपने अनिकेत? This question was asked in GATE 2018. We are talking about. So, आपने आंसर कहां देखा? That is incorrect answer. The answer given is incorrect. The answer should be 2927, 2928. Okay. The next question. This. So we need to find out. The question says the difference in pressure in kilopascal between section P and Q is. Assume acceleration due to gravity is 10 meter per second square. So find out the pressure difference in kilopascal. Find out the pressure difference in kilopascal. So if we write the pressure equation, can you write the pressure equation? Start from point P, PP. Then we are moving in upward direction up to this height. Let me call this height to be H. PP minus water, density of water. We will write the pressure equation in kilopascal only. So PP is the pressure at point P in kilopascal minus rho of water is 1 kilo 1000 kg per meter cube, but we need to write in kilopascal, so divide by 1000. So G, that is 10 into H. Then we can jump from here to here. Then again we can jump from here to here. We are here. Then again we are moving in upward direction minus. Then rho GH 13.6 into G into 0.75. We are here. Now we are traveling in downward direction plus, and we are traveling in water. Then 1 into 10 into 0.75 plus H is equal to PQ. This is the pressure equation, is equal to PQ. So this minus 10 into H will get cancelled out in this 10 into H. So PP minus PQ will be equal to, can you find out the value of PP minus PQ? So it will be 10 into 0.75 negative both, so it will be 13.6 into 0.75 into 10. So 13.6 into 7.5 minus 7.5 kilopascal. 12.6 into 7.5 kilopascal. 12.6 into 7.5. 94.5. It is 94.5. So the nearest option will be treated correct. B will be the correct answer. B will be the right answer. 94.275. It should be 90, exactly 94.5 kilopascal. It should exactly be 94.5. I don't know why they have not given it as. If we take G as 9.81, then also it will not create a problem, na? If we take G as 9.81, the next one, question number 18. A 20 centimeter cubical box slide on oil mass density over a large plane surface with a steady velocity of the plane surface is inclined at an angle of 30 degree. Beautiful question. The plane surface is inclined at an angle of 30 degree and there is a cubical box which is sliding over it. The cubical box is sliding over it like this and there is an oil. The side of the cubical box is 20 centimeter and the velocity is 0.4 meter per second. The plane surface is inclined with the horizontal plane. The oil film between the block and the plane surface is 0.4 millimeter. That is H, thickness of the fluid. The weight of the cubical box is 64. Weight always acts in downward direction, 64 Newton. And if we take normal to this inclined surface, this will be 30 degree. So this is W cos 30, that is Fn, normal force. We are interested in tangential force. Ft will be equal to W sin 30. The tangential force will be W sin 30. The kinematic viscosity of the oil is. So we can write the Newton's law of viscosity. Using Newton's law of viscosity, tau, that is tangential force per unit shear area, is equal to mu into V by H. Assume the velocity profile to be linear. So the question is to find out mu is equal to Ft into H upon As into V. And kinematic viscosity is mu by rho. So into 1 by rho. That will give you the answer. So Ft will be equal to W sin 30, W is 64. So mu is equal to W sin 30, 64 sin 30 is 1 by 2 into H, 0.4 into 10 to the power minus 3 upon shear area. Shear area is the contact area, that is 20 centimeter by 20 centimeter, that is 0.2 into 0.2 area into velocity. What is the velocity? 0.4 into density. Density of oil is 800. That will be meter square per second. What is the answer? This 0.4 getting cancelled out. That is 32 into 10 to the power minus 3 into 10 to the power minus 3 upon 2 into 8 meter square per second. So 10 to the power minus 3, viscosity will be 10 to the power minus 3, isn't it? So kinematic viscosity is 10 to the power minus 3 meter square per second, or 0.001 meter square per second. B is the answer. B will be the answer. Yes, Aniket, it will be 64 sin 30. B will be the correct answer for this one, right? Kinematic viscosity is asked. What will be the dynamic viscosity? Kinematic viscosity into density. 0.001 into, if the question asks you to find out the dynamic viscosity, dynamic viscosity is kinematic viscosity is to density. So 0.001 into 800. 0.8 Pascal second. So if the question asks you to find out the viscosity, it could have been MSQ. The question could have been MSQ. 0.8 Pascal second is dynamic viscosity and this is kinematic viscosity. Both are correct. One is for dynamic viscosity, another is for kinematic viscosity. But the question is about kinematic viscosity. That is why B option is correct. Question number 19. This type of question I had discussed in the class also. Question number 19. Asked in 2011. Consider L-shaped gate. This is L-shaped gate. With water level above the hinge as shown. This is the hinge. The gate is free to rotate about the hinge. Above the hinge as shown. And approximately what height D of the water level will the gate open? Neglect the mass of the gate and assume G as 10 meter per second square. What is the value of D? What we have discussed in the class, this is H, this is B. So I had developed the relation between B and H. So that the gate is about to open. H is equal to under root of 3B if you remember. So it means D is equal to under root of 3 into, this is L, let us say, 2. So that will be the answer. Root 3 into 2, 3.646. Sorry, 3.464. 3.464 meter. A is the answer. A will be the answer. But how? A will be the answer. Do you remember how I solved it? Look. Look. The forces which will develop the moment. About the hinge, we need to equate the moment. So there is a force F1 and there is a force F2. F1 is providing the clockwise moment, F2 is providing the anti-clockwise moment. So what is F1? F1 is equal to rho into G into area. Area is equal to D into 1 into X bar. X bar is equal to D by 2. And this F1 will pass through CP. So this is 2D by 3. So this is D by 3. This distance is D by 3. Isn't it D by 3? Because it will pass through CP. So what about F2? F2 is equal to rho into G into area is 2 into 1. 2 is this 1 into X bar or into D. Because the depth of the centered from the free surface is X bar. Rho G into area into X bar. And this distance will be 2 by 2. That is equal to 1. So for equilibrium, moment about hinge must be 0. For rotational equilibrium. For the rotational equilibrium, net moment must be 0. So we can say F1 into D by 3 should be equal to F2 into 1. Put the values. Rho G getting cancelled out. Rho into G into it will be D square by 2 into D by 3 is equal to, if I call it as L, let me keep it as L. L into 1. Let me keep it as L into 1 into D. And this is L by 2. So this let me call it as L by 2. So rho G into D square by 2 into D by 3. F2 is equal to rho into G into L into D into L by 2. So rho G will get cancelled out. 2 is also getting cancelled out with this 2. 1D is getting cancelled out. So D square by 3 is equal to L square. Or D is equal to under root of 3L. That is the relation. D is equal to root 3L. D is equal to root 3L. This is L. That is how we get this. So the correct answer will be the next one, common data question 20 and 21. A vessel containing water. There is a vessel which is containing water and oil. Another fluid is oil. Density is 800. Pressurized by the gas. The gas pressure above the oil is 2 bar is shown in the figure. Assume that the gravitational acceleration is 10. The pressure exerted on the bottom. The pressure at the bottom will be inside the vessel will be approximately in bar. The pressure in bar. So here there is the 2 bar pressure. If you write the pressure equation, that will be 2 bar plus 1 bar is equal to 10 to the power 5 Pascal. So divide by 10 to the power 5. Rho into G 8000 into 1. So it will be 0.8 plus 1000 into 1 to 3. This is 3 meter. Or let me write this way. 2 bar, it means 2 into 10 to the power 5 plus rho of oil 800 into G into 1 meter plus rho of water into G into 3 meter, that is Pascal. So 1 Pascal is equal to 10 to the power minus 5 bar. So if you want to convert, then multiply by 10 to the power minus 5. So 2 plus, is it 0.8? (0.08) plus 0.3 bar. So 2.38 bar will be the correct answer. Isn't it 2.38 bar? It is 2.38 bar. (2.38 bar). B will be the answer. Now the gate is 1 meter wide, perpendicular to the plane of the paper. The force exerted on the gate is approximately the force which is exerted on the gate. So we can call it as average pressure into area, because the pressure varies linear. Pressure is the linear function of Z. So we can find out the average pressure as P minimum plus P maximum by 2. So average pressure is here. So the bottom pressure we already know. So average pressure on the gate will be equal to PB minus rho of water into G into 1 plus 0.5. That will be the average pressure. Average pressure into area. So what is the average pressure? It will be, the answer should be in Newton, na? So it will be 2.38 into 10 to the power 5. 2.38 into 10 to the power 5 minus 10 to the power 4 into 1.5 Pascal, multiplied by area 1 into 1. So force is equal to average pressure into 1 into 1. So it will be in terms of 10 to the power 4. So if we take 10 to the power 4 common, then it will be 23.8 minus 1.5 Newton. What is 23.8 minus 1.5? 22.3. 22.3 into 10 to the power 4 Newton. 22.3 into 10 to the power 4 or 2.23 into 10 to the power 5 Newton will be the correct answer. Isn't it C? 2.23 into 10 to the power 5 Newton will be the right answer. C will be the answer. The next one, question number 22. Let us talk about question number 22. There is a dam with a curved shape is shown in the figure. This is the dam. The cross-sectional area of the dam, which is the shaded portion, is 100 meter square. The area is 100 here. And its centroid is at x is equal to 10 meter. Where is it shown? Its centroid is at x is equal to 10 meter. This is the centroid, that is 10 meter. X bar is 10 meter. This is the centroid. It is as x equal to 10 meter. The vertical component of the hydrostatic force Fz, it will be downward because the fluid is in contact from the top. The vertical component of the hydrostatic force Fz is acting at a distance xp. This is actually xp. This is xp. The value of xp is, so how to find out the value of xp? Equate moment, this is xp. If we equate moment about the free surface, about this OZ, if we equate moment about OZ, the total moment is equal to sum of moments m1 and m2. What is the total moment? If we take this total, so area into width is 1, let us say. What is the area? 15 by 40, 40 by 15, that is the total area, into the centroid of this 15 is equal to 7.5, yes or no? Into 7.5, we are taking the moment about OZ, is equal to m1. Let me take m1 as this is 1, this is 2. So m1 will be, area is 100 into this is 10 plus this area will be 40 into 15 minus 100. This will be the remaining area into xp. Because the way the hydrostatic vertical component of hydrostatic force is the weight of the fluid which can be contained by the curved surface up to the free surface. So into xp. So from here we can find out the value of xp, isn't it? 600 into 7.5 is equal to 1000 plus 600 minus 100, 500 into xp. That will give you the value of xp. That will give you the value. These two 0 getting cancel out. So xp is equal to 6 into 7.5 minus 10 divided by 5 meter. 7.5 into 6, 45 minus 10, 35 divided by 5, 7 meter will be the answer. Do you understand? Equate moment about the free surface. What is the value of force? Can you find out the force also? Can you find out the force? Fz. Fz is equal to rho of water. Fz will be equal to, the fluid is not given. Let me assume it as water. Rho of water into G into this volume. How to find out this volume? Then again this volume is 40 into 15 minus 100. So it will be 10,000 into 500 Newton. It is almost this Newton. It is around 5 mega Newton. The force will be around 5 mega Newton if the fluid is water. It will be around 5 mega Newton. 5 into 10 to the power 6 Newton. This will be the answer. This question was asked in 2014. The next one. Yes. It is around 5 mega Newton. Close to 5 mega Newton. Let us talk about the next one. A container of a square cross section. There is a container of a square cross section like this. Is partially filled with the liquid of density rho 1. there is the liquid which is having the density rho 1. The cylinder or the container. The container is intended to float in another liquid of density rho 2. Outside fluid is rho 2, inside fluid is rho 1. As shown in figure. The distance between metacenter and center of buoyancy is given by this I by V, where I and V submerged are the moment of inertia of the cross section and the submerged volume. Neglect the weight of the container. Which of the following is the correct condition for stability? What is the condition for stability? For stable equilibrium, we can say Gm metacentric height, that is Bm minus Bg, should be positive. For stable equilibrium, metacentric height should be positive. So first of all, we will find out, this is H. We will find out the depth of immersion X. First of all, find out this X. X is the depth of immersion. How? For vertical equilibrium, buoyant force exerted on the container is equal to weight of the fluid in the container. What is the buoyant force? Buoyant force is, the fluid is rho 2 here, this is rho 1. Right? So buoyant force is exerted by rho 2 into G into volume of the fluid displaced. If this is B, this is B, this will also be B. So rho into G into volume of the fluid displaced. So B square into X is equal to the weight of the fluid in the container, rho 1 into G into volume of the fluid in the container, that is B square into H. B square getting cancelled out, G and G also getting cancelled out. So X will be equal to rho 1 H by rho 2. X is equal to rho 1 H by rho 2. That is first expression. Now what is Bg? Bg is equal to H by 2 minus X by 2. And X is equal to H by 2 minus X is equal to rho 1 H by rho 2 into 1 by 2. So it will be H by 2 multiplied by 1 minus rho 1 by rho 2. That is Bg. Now Bm is equal to I xx upon volume of the fluid displaced. What is I? B to the power 4 upon 12 into volume of the fluid displaced is B square into X. So it will be B square by 12 into rho 1 H by rho 2. That is Bm. So for vertical equilibrium, sorry, for a stable equilibrium, Bm minus Bg should be greater than 0. What is Bm? B square, or let me write, implies B square into rho 2 by 12 rho 1 H minus H by 2, 1 minus rho 1 by rho 2. Should be greater than 0. If we take B by 2 common, here, if you see the options, it will be B by 6 something. So if we take B by 2 common, then it will be rho 2B upon 6 rho 1 H minus B by 2 common. If we take B by 2 so it will be 2 by B into H by 2, 1 minus rho 1 by rho 2 greater than 0. This 2 getting cancelled out. So if we take B by 2 on the right hand side, so it will be rho 2 into B upon 6 rho 1 into H minus H by B, 1 minus rho 1 by rho 2 should be greater than 0. That will be the condition. Rho 2B upon 6 rho 1 H minus H by B, 1 minus rho 1 by rho 2 should be greater than 0. That should be the condition. A will be the correct answer. Option A will be the answer. Option A. Are you getting it? Question number 24. Try to solve this one. Water is retained against a sluice gate. This was asked in 2015. Water is retained against a sluice gate in the form of a circular segment. The gate is in the form of a circular segment of radius r. If Q and G are the density of water, Q is the density of water and G is the acceleration due to gravity, the upward force exerted by the gate on the water. Upward force exerted by the water on the gate. By the water on the gate. The upward force will be exerted by the water on the gate per unit depth perpendicular to the plane of the figure. What is the upward force? Upward force is buoyant force. Net upward force is nothing but buoyant force. So we need to find out the buoyant force exerted by the water on the gate. So buoyant force is exerted, that is equal to weight of the fluid. Buoyant force is equal to weight of the fluid displaced by the body, isn't it? This is how we will get the upward force or buoyant force. This will be the buoyant force. So if we can find out this volume, how to find out this volume? If we complete it, this is a circle. It is a circle of like this. This is a circle like this. So if we can first find out this volume, width is 1. So this volume will be equal to, 2 theta upon 2 pi into pi r square. Yes or no? 2 theta by 360 upon pi r square. This is the area into 1. This will be the volume. We are volume of the fluid displaced. This minus, if we can find out the volume of this triangle, so the base of the triangle will be equal to, what will be the base of the triangle? It is r cos theta. The height of the triangle will be r cos theta. This will be r sin theta. And it will be twice. This is also r sin theta. So if we want to find out the volume of the triangle, then half into base is 2r sin theta into height is r cos theta into 1. We are interested in volume. This is how volume of the fluid displaced is equal to this 2 getting cancelled out. So, and pi also getting cancelled out. So theta into r square minus 1 by 2 into r square. Then 2 sin theta cos theta is equal to sin 2 theta. Sin 2 theta. That is the volume. That is equal to, if we take r square common, then theta minus sin 2 theta by 2. That is the volume of the fluid displaced. And buoyant force is equal to rho of fluid into g into volume of the fluid displaced. Density of the fluid is q. Density of water is given as q into g into r square into theta minus sin 2 theta by 2. That will be the answer. That is the buoyant force. Q g r square theta minus sin 2 theta by 2. Q g r square theta minus sin 2 theta by 2. Option A. A will be the answer. Yes. Option A will be the correct answer. Well done. The next question number 25. The next one, question number 25. An open, this was asked in 2015, an open glass capillary tube of 2 mm bore, the diameter is 2 mm, is lowered into a cistern containing mercury. The fluid is mercury. Density is 13,600 as shown in figure. Given that the contact angle between the mercury and glass is 140, that is theta. which is greater than 90 degrees. So there will be capillary fall. There will be capillary depression. Surface tension coefficient, that is sigma 0.484, and the gravitational acceleration is 9.81. The depression of mercury in the capillary tube below the free surface is, H is calculated by 4 sigma cos theta upon rho into G into D. If we are getting it as positive when theta is less than 90 degree, then there will be capillary rise. If we are getting this value as negative when theta is greater than 90 degree, then capillary fall. So there will be capillary fall because cos theta will be negative, but the magnitude can be calculated as, so can you calculate the magnitude? H is equal to 4 into sigma. 4 into sigma. 4 into sigma is 0.484 into cos of 140. You will get a negative answer. No problem with that because depression is asked. So do not take the negative sign. Rho of fluid is 13,600 into G is 9.81 into diameter 2 mm. That is 0.002. That will be meter. So H will come out to be cos of 140 into 4 into 0.484 divide by 13,600 divide by 9.81 divide by 0.002. 5.558 into 10 to the power minus 3. 5.558 into 10 to the power minus 3 meter, that is negative. The value will be negative. So in millimeter, how much is that? That will be 5.558 meter. In meter, it will be 5.558. Isn't it? That will be the answer. One more question. This is again wonderful question. Consider incomparable flow through a two-dimensional open channel. At a certain section AA, the velocity profile is parabolic. U is a function of y. This is y and this is parabola. Neglecting air resistance at the free surface, find the volume flow rate per unit weight. Because U is a variable, so at any y we will calculate the discharge volume flow rate. Q is equal to integration of U into dy into 1, isn't it? And the limit will be from 0 to 2, y is equal to 2. The only problem is to develop the relation between. Now we need to develop a relation between U and y. Now if you see this curve, if the velocity profile is like this, then isn't it U square is equal to ay? If the parabola is like this, that means y square is equal to 4ax. If the parabola is like this, then it will be x square is equal to 4ay. And in x direction velocity is there and in y direction y. So it will be u, because this is the curve. So u square is equal to ay. So at y is equal to 2, u is equal to 10. So 20 is equal to a into 2. A into 2. At y is equal to 2, u is equal to 10. At y is equal to 2, u is equal to 10. This is the condition. We can find out the value of a. At y is equal to 0, u is equal to 0. We could have written b also. So b is equal to 0. So y is equal to 2. So a will be equal to 10. So u square is equal to 10y. That is the relation. Or we can say u is equal to root 10y. u square, my mistake, u square is equal to ay, u square is 100 is equal to 2, so a is equal to 50. हाँ देखिए, हरे कृष्णा में रिपीट कर देता हूं, ये कर्व ऐसा है, this is u and this is y, the relation is between u and y, there is a relation between u and y, isn't it? So to find out the discharge, we need to find out discharge in small element dy. Now our objective is to develop a relation between u as a function of y. That is our objective. If we get this, here you can say y is always positive, y is not negative. The curve is like this, y is always positive. So y is equal to, so u square is equal to ay plus b is our assumption. This is our expression. Assume u square is equal to ay plus b. That is the parabolic relation. That is general parabolic relation. So at y is equal to 0, u is equal to 0, implies b is equal to 0. At y is equal to 2, u is equal to 10, y is equal to 2, u is equal to 10. So implies a will be equal to 50. So u square is equal to 50y is the expression, or you can say u is equal to under root of 50y. This is our expression, root 50y. Now q is equal to integration 0 to 2, u is equal to under root of 50 into root y into dy. Do the calculation, root 50 is outside. What is the under root of y dy? 1 by 2 plus 1, 3 by 2, y to the power 3 by 2 into 2 by 3, 0 to 2. So it will be q is equal to under root of 50 into 2 by 3 into 2 to the power 3 by 2, 1.5. This will be the answer. What is the answer? This will give you the answer. Can you solve it? Under root of 50 into 2 by 3 into 2 to the power 1.5. 13.33 will be the answer. The answer will be 13.33. The parabolic is given, na? It is given by the parabola. The velocity profile is given as parabolic. That is why. So 13.33 will be the correct answer. One last question before we end our session. Common data question. The velocity field for a two-dimensional flow is given by, this is ui cap plus vj cap. So what is the total acceleration? A total. A total is equal to axi cap plus ayj cap. You can easily find out. So find out the total acceleration. U is equal to x by t and v is equal to minus y by t. So ax is equal to del u by del t plus u into del u by del x plus v into del u by del y. Del u by del t is differentiate x into minus 1 into t to the power minus 2. Right? Plus u into del u by del x. U is x by t into del u by del x is 1 by t. V into del u by del y. U is not a function of y, so this will be 0. So it will be minus x by t square plus x by t square. So ax will be equal to 0. Ax will be 0. Here ax will be 0. So this cannot be correct. This cannot be correct. This cannot be correct. The only option is D. The only option is D. You can find out Ay also. Del V by del T, local acceleration, plus U into del V by del X, plus V into del V by del Y. Because V is not a function of X, so this will be 0. Del V by del T is minus Y into minus 1 into T to the power minus 2, plus V minus Y by T into del V by del Y minus 1 by T. So Ay will be equal to, it will become Y by T square plus Y by T square. So Ay by is equal to 2Y by T square. So Ay is 2Y by T square. So the answer will be 2Y by T square into J cap. That will be the answer. And the given velocity field is incompressible and irrotational. So for continuity equation, apply the continuity equation. Del U by del X plus del V by del Y. If it is 0, then it is incompressible. What is del U by del X? 1 by T plus what is del V by del Y? Minus 1 by T. Because it is 0, it is incompressible. And for irrotational, vorticity, del V by del X minus del U by del Y is equal to 0. Minus del U by del Y is equal to 0. So what is del V by del X? V is not a function of X. 0 minus 0 is equal to 0. So it is irrotational also. It is irrotational as well as incompressible, right? So I am giving you one assignment question. Try to solve this question, and if you find any difficulty, you can. The question is very much similar to the question I have discussed just now. So try to solve this and share me the answer through the comment section, or you can share your answer to my Telegram channel. All right. So that is all from my side. You can download the Byjus exam prep app for more practice sessions. There are quizzes available. You can practice on our Byjus app as well. And you can join me on the Telegram if you are not part of my Telegram channel, because I will share the PDF of this session to my Telegram channel only. All right. So with this note, let me take your leave. Thank you very much for joining in. See you in the next such session. Till then, enjoy, take care, have a great career ahead. Please do not stop practicing, do not stop working hard. The only key to success is your consistency and your hard work. All right. So thank you very much. Take care. Jai Hind. Yes, Aniket. Yes, Aniket. What is the question? Tell me. There are some more questions here. Acha, Aniket, I will share. You don't have the notes? But I don't have short notes actually. Either if you want, I can send you the marathon session notes, or if you want, I can share the full length notes. Which notes you want? Marathon notes or the full notes of FM? Okay, I will do that. All right, guys. Thank you very much for joining in. Full length, I will do that. Please ping me on WhatsApp. I will do that. Thank you very much once again. Take care. See you in the next session. Mm-hmm.